Okay, so I've gotten some questions on arrays in my office hours and over email, and I thought it would be better to do something like this just to make sure everybody's on the same page instead of getting back to those specific questions individually. So hopefully by the end of this, it'll be a nice way to familiarize yourself or hopefully refamiliarize yourself with some of the concepts on arrays and what they are and how they work. So of course, like the big three types of questions I've gotten are, the what, like what are arrays, and then the why would we use them, and then sort of the how, right, the specific implementation of arrays in the C programming language, and we'll go over all three of these. Uh, so starting with the what are arrays? Well, if you take your normal variables, right? And this is where you'll have things like int x equals 5, right? That's something that everybody should hopefully be familiar with. We have an integer, we're calling it x, and we're saying that it's equal to 5. You can sort of think of this as being like a little box, right? And the box is being labeled x. And inside the box, we're putting the value 5. And all of your variables sort of work like this. You make a variable, and it sort of is like this container for the value that you're assigning it to. When you're dealing with arrays, it's sort of like taking a box, just like any other variable, and then extending it to be able to contain multiple values and keeping them all in the same place. And we're not talking about the why specifically yet, but this is sort of the big advantage of an array is it allows you to group like sets of data, similar sets of data or values in one place, so you don't have to make all kinds of variables. You can just store them in one variable. So maybe we have, well, we'll just call it R, right? And this is where we're talking a little bit about how to sort of conceptualize arrays, right? So in this example, I'm calling it R, just like I called this variable x. And we see here, as opposed to being just a box for one value, this is actually a larger box that contains space for 5 values. And the way that we sort of denote that in C is by when we declare the array, we inside the braces, and it's sort of easy to remember to use the braces, because if you're thinking of arrays in this sort of box conceptualization, then this sort of looks like a box, right? And it has space for 5 values. So we could say to make an array of size 5, which is like a box with space for 5 values, we could do it this way. Open brackets, the size of your array, in this case it's 5, and then close brackets. And this is how we can sort of declare our arrays. So now, of course, it wouldn't be very useful if we didn't put anything in the box. So just for example's sake, we can just fill this with some random numbers. It doesn't really matter what they are. Maybe in an actual program we might have some more pattern or rhyme or reason to it, but for now it's not too important what the specific numbers are. So why would this be useful? Well, we know, and we haven't talked too much about the specific implementation, but we do know for a fact that all of these values in this box, in this array, are somehow related to one another. We don't need to make 5 separate variables. We just need to work with this one array variable. And we'll talk about how to do that once we get to the actual C language. But that's the main advantage of arrays. Instead of declaring 5 separate variables, we can relate all of these values to this one variable and just reference it using the specific implementation in C for working with arrays to reference all of these values. So let's talk a little bit about the how. So we've declared our array, int array equals 5. I'm actually going to erase this because this is the, well, I'll put it up here. So this is to make an array of size 5. Int array equals, well, nothing yet. But that's just to make an array of size 5. And of course, I'm calling this R. You could call this whatever you want. You could call it array, you could call it grades. This is just a variable name, just like any of the rest of them. Of course, this isn't very useful if we don't have a way to actually populate it. So this is called auto-initialization, when we assign values to our variables, or in this case to our array, at the declaration stage instead of doing it later. So we're going to auto-initialize this array. So it starts off similar. We'll use an equal sign. Instead of using braces like this, we're going to use curly braces, and we're going to fill in the values that we want our array to contain and separate them by commas. So hopefully this will make sense. 74, 65, 13. These are just examples. The specifics don't matter too much right now. So hopefully this makes sense so far. So we have an array of size 5, and we're saying that it's going to contain these values that we have separated by commas. Hopefully that's pretty clear. So in this example up here, we're dealing with an array that we didn't auto-initialize. We just declared it and set space for 5 values. In here, we're declaring an array with space for 5 values, and we are actually initializing them. So we have all these values stored in this array, which is sort of this sort of visual representation. This is how it would actually be implemented in code. It wouldn't be very useful if we didn't have a way to pull out specific values that we wanted. We don't want to necessarily always refer to all of these at once. Maybe we want access to just the 13 or just the 22, or maybe we want access to the first one, then the second one, then the third one, then the fourth one, then the fifth one. And this is sort of when we get into more of the specific implementation. So as I'm sure you've probably seen in class or online or somewhere that these are numbered, the little cells in the box, right? And this is the first one, the second one, the third one, the fourth one, the fifth one. But in the C language, we don't start numbering, or we call it indexing them from 1. We start indexing them from 0. So actually, this first box up here is, you can think of it as being the 0th box, right? And then you can think of this box over here as being the first box. This box as being the second box. This one as being the box at position 3. And then finally, this is the box at position 4. And I'll give you little arrows just so we can all be on the same page with that. So this is going into this one. This is going into this one. Like that. So of course these aren't the values. So I'm not saying that this box contains the number 0. It contains the value 51. But it is at the position or the index of 0. And then 1, 2, 3, 4. How do we reference these specific values in C? Well, if our array is called R, it's very easy. All we have to do is, after we've already declared it up here, from then on, we can reference them by saying R and then giving them the index. So in this case, R sub 0 will be the entire array at the position 0, which will give us the value of 51. And similarly, R sub 1 gives us the value in the first cell of the array, well, the one cell, the first cell is 0, which gives us 22. R sub 2 will be 74, and so on. So now let's actually go ahead and open up a C program and see what this sort of looks like in code. And this is what I was talking about. I'll give you sort of the reason, a little refresher of why arrays might be important. So say we want to work with these 5 values. We can do int val1 equals 51, int val2 equals 22, int val3 equals 74, int val4 equals 65, and int val5 equals 13. So now we have these 5 values, and to work with these would be sort of tedious, right? Because we have 5 different variables that we don't necessarily want to be working with 5 different variables. So arrays give us an alternative to this. We can do just like we said over here, int array 5 equals, and then give it the values. So we'll go ahead and do that. 51, 22, 74, 65, and 13. So we've declared our array, and remember this is an integer array with space for 5 values, and these are the 5 values. So now we can just go ahead and let's try and reference them. So like we said, array at position 0 should be 51. So let's go ahead and do a simple printf, and because these are integers, we're still going to use %d. Nothing's changed there. And let's see what printing array at position 0 gives us. We run the code, and it gives us 51. because that's the first element in the array. And I'm just going to go ahead and copy and paste these in and start changing these. So we can go down sort of the list of numbers in here. And there's 3. And there's 4. And remember, even though the array is of size 5, the last element in the array won't be 5 because we're starting from 0, so it'll actually be 4. And this is a good thing to write down, to sort of make a mental note of, or maybe a physical note of. If an array is of size 5, then the first element will be at position 0, and the last element will be at position 5 minus 1, which equals 4. So more generally, if an array is of size n, which means you have n elements, then the last element will actually be at position n minus 1. And that's a good thing to know. So if you see a test question where it's like you have an array of size 5 or an array of size 10, and you want access to the last element in the array, know that you're not going to be doing, array sub 10 or array sub 5. You're going to be doing array sub 9 or array sub 4, or whatever the size is, minus 1. That's a really important thing about arrays, and it's also really important to know that you start counting from 0 and not from 1. So we'll go ahead and run this just to verify that it works. And we have 51, 22, 74, 65, 13. So now we can do some things where we, let's try changing the value. Let's say we want to update the value in the third slot in the array, the 74. That's simple enough to do. We just use the name of the array, and we know that we're starting counting from 0, so we'll do 0, 1, 2, and we're referencing now that element. And we can just update the value just like we would any other integer. So we can say maybe we want to set it to 85. We'll go ahead and print out the new value just to be sure that that works. And let's go ahead and run this. And the last thing we see printed is the 85 that we just wrote up here. So that's how you assign values to an array. That's how you print or reference the values in an array. And you can also update the values in an array. So what that actually means is instead of doing it this way, where you auto-initialize the array, I'm just going to go ahead and comment this out. And this is an auto-initialization. Where we're assigning the values immediately. We have the option of doing it this way, where we just declare the array and how large we want it to be. So in this case, we want it to be have space for 5 values. And then we can sort of declare them all separately. So we can do something like this. Referencing the 0th element in the array, which will be the first one, we could just set that to 51. And then we could set this one to 22. We could set the second one, or the third one really, but we're counting from 0, to 74. This one we could set to 65. And the last one we could set to 13. And if we run this, we'll see that we get the same results. So that's another thing to know about arrays. This is an auto-initialization. If you know what your values are going to be ahead of time, you can do it this way. If you don't know what they're going to be ahead of time, then you can just declare space for your array, and then you can sort of fill them out later on. So what that means is that we could actually prompt the user, please enter a number, and we could scan it in. We could scan it in just like we would scan in any other variable using the ampersand array sub 0. And whatever they scan in will be the new value at that position, right? So this is another way to sort of populate our arrays. Ooh, I didn't close my parentheses. Undeclared. Oh, sorry. This is just like in class. So please enter a number. I'm not going to enter 51. I'll enter something like 20. And we see that that works just as well. So we're able to scan numbers into an array, referencing them using this the bracket and the index that we want it at, and something like that. So we could do this for the entire array if we really wanted to. But you might notice that this is sort of taking up a lot of code, right? There's a lot of sort of repeated things. In fact, in printing all the elements in an array, or in assigning all the elements in an array, or scanning all the elements in an array, you'll see that we're going 0, 1, 2, 3, 4, up here 0, 1, 2, 3, 4. It's like we're counting up by 1 each time. So maybe instead of hard coding it the way we're doing, there might be a better sort of implementation for how we could sort of navigate elements in an array. Sort of the way to handle that is I'm going to go ahead and comment all this out, put it down here, and come back up to the top. So we're not going to be really doing anything new, but we are going to talk about using arrays in conjunction with loops. So if we wanted to prompt the user to enter a number for every element in the array, please enter a number, we would have to have a scanf, right? Just like we did before. And we would have to do this and copy and paste it 5 times for every element in the array. For the 0, the 1, the 2, the 3, and eventually for the 4. So the way to get around this is, instead of copying and pasting it, since we recognize that first we want the 0 index, and then we want the 1 index, and then we want the 2, and then the 3, and then the 4, we could just use a loop. So let's talk about how we would do that. We'll need our counter variable. We'll use I. And we'll loop from I equals 0, which is where we want to start at, to I is less than, let's say, 5, the length of the array. And let's notice something first. If we print I at every iteration of the loop, right, and we just run this, you see that I goes from 0, 1, 2, 3, 4. If you come down here, when we're trying to print every element in an array, it's 0, 1, 2, 3, 4. So what that means is that, I should really be closing these. What that means is that we could just use I for indexing our array if we want to do something like print all the values or scan all the values. So let's go ahead and make that happen. We'll printf, please enter a number, and we'll scanf %d, and normally down here we were doing, array sub 0 or array sub 1, but since we know that I is going to start at 0, increment by 1 each time, and make it to 4, we can just do array sub I, and since this will happen 5 times, it'll let us scan the array or elements into the array 5 times. So if I run this, oh, sorry, need the ampersand. If I run this, you'll see it's going to let me do this 5 times. And now, let's go ahead and write another loop to print the elements of the array. So I'm going to do the same thing. I is less than 5, I plus plus. Do it this way. And here, this is the %d element of the array, %d, \n. And the first one is going to be I, and the second one is going to be array at position I. And we'll notice something's going to happen here when we actually go to run this. 66, 55, 88, 11, and 10. So it is printing the numbers out properly, so this does work. But because I is starting at 0 and making it up to 4, it might be 1 less than we want it to be, even though these are the proper elements of the array. So if you want this to count from 1 to 5, the only thing you would have to do is, instead of saying I, you can say I plus 1, and then we go to run this again, and we'll see that it works counting from 1 to 5 instead of from 0 to 4, and it still prints the elements of the array properly. So for one more example, before I sort of wrap up this topic, I want to do something where we can actually implement arrays in a useful and meaningful way. So I have this snippet of code for a very simple gradebook program. So let's talk about what this does. We have these 5 grades that we want to declare here: grade 1, grade 2, grade 3, grade 4, grade 5. Maybe this is a class that has 5 tests, and we want to sort of store all the students' grades. And then the next thing it does is it prompts the user to enter the grades. So please enter a grade for exam 1, and then you scan it into grade 1, grade 2, grade 3, grade 4, grade 5. And the last thing it does is it displays the grades. Grade 1, grade 2, grade 3, grade 4, grade 5. So this isn't too dissimilar to what we were doing down here. So what I'd like to do is sort of use arrays we would call this refactor, or change the code to make it more concise, and modify it from this to something that's maybe a little bit more readable and more maintainable. So we know we have 5 grades that we want to work with. So let's go down here and we'll declare our array, and we can just call it grades. And we know we need space for 5 integers. So already, instead of declaring 5 variables, we've just done this with declaring 1 array. So this gives us space for 5 integers, this gives us 5 integers. So this part is done. We want to prompt the user to enter grades. This is pretty similar to what we were doing here, right? I'll make an iterator for our for loop. So enter the grade for exam 1, enter the grade for exam 2, enter the grade for exam 3. We know we can do this with a loop since we did this a couple minutes ago. So I'm going to please enter a grade for exam 1, 2, 3. I'll do it like this. Printf, please enter a grade for exam %d. And what's the %d going to be? It's just going to be, like we talked about, I plus 1. Because I starts at 0 and it goes to 4, we want to enter 1 through 5. So that'll take care of that. And then we're just going to scanf, just like we did back down here, %d, and then ampersand array at position I. And this is the exact same thing we were doing in this for loop, actually. We're just using it to refactor this section of code. And then the last thing is to actually display the grades. We can do that like we did earlier with another loop. I is less than 5, I plus plus. So we'll go ahead and printf. And what did I say? Your grade on exam. Yeah. Your grade on exam %d is %d \n. And the first %d again will be I plus 1, and the second %d will be grades at position. Sorry about that. This should be grades, not r, because that's the name of the array we're working with now. So this should be grades at position I. So let's go ahead and try and run this. And there's no errors. So enter a grade for exam 1, 96, 55, 10, 45, and then it displays the grades for exam 1. And the reason it's asking me to do it again is because this is this section of code. So it executes all of this, and then it's going to come down here and start executing the original version of the program. So I can do it again just to show you that this version of the program does work. And you'll notice that the output is exactly the same for both versions of the program, but this one goes from line 11 to 24. So it's about, what is that? 13 lines long, or is that 23? Yeah, so 12 lines long, whereas this one goes from 26 all the way down to 50. And instead of working with 5 different variables, you only have the one array variable that you have to work with. So definitely an improvement in terms of maintainability, and that's really the main advantage that you have when you're working with arrays. So hopefully that cleared some things up for you. Hopefully this all makes sense. I'll go ahead and post all this code on web courses, so we can comment some of this stuff out, or maybe I'll just leave that. Yeah, so I'll post this on web courses. Hopefully it all makes sense, and let me know if you have any more questions on arrays that I didn't get to.